Good afternoon, dear students. Today, in the third lecture, we will we'll discuss the steps that are involved in a research work. So, how to follow the research methodology, systematic investigation of the research problem. The research methodology teaches us. So, we will start with the steps involved in a research work. Last two lectures, we have discussed the philosophy of research, what type of different research works people do. And now let's go to discuss the steps that are involved in carrying out the research work. So I discussed this slide in the last lecture. These are the steps that are involved in carrying out the research work. Formulating the research problem, and which requires the extensive literature survey. We'll discuss this today in today's lecture. And subsequently, we will discuss if it is a hypothesis driven research problem, then how to develop a hypothesis. We'll discuss that in the next lecture. And based on that, we can prepare the research design. Basically, we make a roadmap for carrying out the research. Some of the research problems may require sampling. So how to do sampling. Some of them may require simulation, how to do simulation. Then collecting the data, that is a part of the execution of the program, of the project. Subsequently analyze the data and also do a statistical analysis of the data to see that whether the data are okay, correct or not. What is the precision and accuracy of the data. Then we can test this hypothesis, whether the null hypothesis is rejected or not. So we will discuss that part later on. And based on the outcome of this hypothesis testing, or if it is a just measurement of a value, then statistical analysis is important. And we generalize the results, interpret the results in view of what we had envisaged in the beginning of the research problem. Then based on that, we write the research paper or thesis and also present our work in different platforms like conferences and symposium. Okay. So these are the steps that are involved in a research problem when you are doing research. So research process consists of a series of actions or steps that are necessary to carry effectively the research work. And so the sequence of the different steps are given below. So first thing is that we define the research problem. Exactly, specify once we choose a topic of research, but in that topic also we define a research problem, which we may be working for a period of 6 months or 1 year, or even it could be even more than that. So to define that problem, we need to do an extensive research literature survey to confirm that it has not been done, or what knowledge is already known by this time about this research problem. So this is an important part of the research work. And based on this literature survey and how to define the problem, we formulate the hypothesis, and subsequently we make a design like a roadmap for the carrying out the research. So whatever I discussed in the previous slide is in the block diagram form. And then we collect the data, like execute the projects, analyze the data, and there is a now feedback mechanism, because many a times you may not get the correct data, or there could be some problem with the data. So you go and give a feedback and remodel the research design. Similarly, when the analysis is done, we test the hypothesis and we make the interpretation, make a report, and then you will notice that from that problem, many other research problems arise. So there is a feedback mechanism from the outcome of one study to develop new problems, and we again go back to the defining the research problem. It could be a subset of the first problem, or it could be an extension of that. It could be a totally new problem, depending upon the outcome of this particular work. Okay, so to ensure that you don't really waste your time, because you many a times you will find you are spending a lot of time, but no outcome is coming. People are spending. So I remember, I know that the usual time is 5 years, but some of the students very few used to also go up to 8 years and sometimes 9 years. So this could be because of the improper planning of the research problem. So this is what we have to learn as a part of this research methodology. So if you take these steps carefully, you will save a lot of time and efforts. In fact, after 5 years, you know that you don't get this scholarship. So if it is planned properly, one can finish it in 5 years or maybe 6 years. So the problem should have a clearly defined purpose. We will discuss more on this subsequently. Then you make a detailed description of the research procedure in such a way that it can be repeated by others. See, research work, whatever you do, it should be done, and you have to narrate in such a way that other group, your peers can repeat the work and get the results. So this also applies to writing a paper. When you write a paper, you write in such a way that any person in anywhere in the world can able to repeat this experiment and confirm whether what you have concluded is right or not. So you have to then carefully plan the procedural design of the research to yield the meaningful results. So many a times, because of lack of proper planning of the design, we don't get the proper results. So it is very, very important part to make a proper research design. Also, the frank reporting of results, including the flaws. If there are any flaws, it is always report the flaws if there are any problems. So particularly, is some of these there are situations where you don't have a good resolution. So you have suppose you have two peaks nearby, resolution is broad, and they are merging together. You feel there is only one peak. So that kind of things and can lead to a lot of erroneous results, conclusions. So you have to plan the experiment very carefully so that you get meaningful results. So the results, whatever are obtained, have to be reported very frankly. Adequate analysis of data to reveal its significance. So many a times, like signal to noise ratio is very important. We are looking for a very small peak in a large noise. So how significant is the signal or the peak? That's very important. You have to do proper statistical analysis to tell whether the peak is significant or not. Then check the validity and reliability of data carefully. So whatever data you are generating, they must be correct. They should be reliable. Confine the conclusions to those justified by data. It is very important step. So when we analyze, our instrument has some limitations. And when we get the results, we want to conclude about the present study that we have done. But many a times we extrapolate the outcome of our study to an area which we have not been able to intrude. So it is very, very important not to conjecture or conclude beyond what is written, what is concluded by the data. So that is very important part. And then in all this, when you are publishing, the experience, the reputation, and the integrity of the researcher warrants greater confidence. So you will get the confidence with time. Once you start publishing your work, then you establish your reputation in the academic world, and people know that this is the group which will not make silly mistakes in when publishing. So, but that happens quite late. Even in the beginning itself, your data will be always looked at through suspicion. If you are doing the work for the first time, you are starting the work, so you have to learn how to give the significance of your work, and also tell how to write that your data is correct. So you have to provide the validation of your data, the data is statistically significant and correct. So let us discuss how to define a research problem. So the starting point of your research, like your thesis work, is selection of a research problem. What problem one should be working on, and you will find that gradually, as a corollary to that particular first problem, many other problems will appear. Identifying a suitable topic. So before you define a research problem, you have the broad canvas. So mostly when you join a particular institute, you know the faculties and their area of interest of the faculty. And then you know this particular faculty works in this area, this topic. In that topic, then you have to choose what problem to work. So this is in fact the most difficult part of the research problem, how to identify the research problem. Or even the topic also. Many a times, there could be some, the guide may give you a broad canvas and you have to choose from the topics that he is working on. So before choosing the topic, keep in mind whether the topic is suitable for research or not. Important part, though it is written in a simple language, but is very significant, whether it is suitable to do research in this area. And whether you are interested in it. The guide has given you a problem, research topic, this is the topic on which you should work. But you should be also convinced that yes, there is a merit, and also I am interested in doing this work. This is important, and you must have an interest in carrying out that particular such work. Then topics should not be chosen by compulsion from someone else. So you have been told this is the problem you have to work on. You don't feel compelled because it is a PhD problem. If it is a departmental program, then it is fine. But if it is your PhD problem, you have to think freely whether you are interested in pursuing this work. In most of the cases, your supervisor will be giving you a good problem. So consult your supervisor while fixing the such problem. And you have to also ensure that whatever research problem you are going to tackle, it adds new knowledge in the field of your subject. So this is you can ask your supervisor, what is it that new that you will be adding to the knowledge pool once you take up this problem? So these are the important aspects you have to choose, think about when defining a research problem. Okay. So let us discuss little more by some examples and how to identify a research topic. So avoid subjects which are overdone. So there have been studies, going on for the last 50 years, and you will still find people working on those areas by adding a very small delta knowledge. So if an old area, with overdone area, does not throw much light on that subject. For example, many of my students may not agree with me that low energy and medium energy fission, in terms of the mechanism of this, it's not that you are using this for some application, but if you are doing fundamental research in low and medium energy fission, this has been thoroughly studied for the last. Now the fission was discovered in 1938. And the mechanism of the fission process has been studied very, very thoroughly. Of course, the high energy fission is still a topic of interest, but low energy and medium energy you will find, though you will find papers being published in physical review even now. But that is where one has to be convinced that yes, there is interest in still studying this. So, and then avoid controversial subjects. For example, this cold fusion. Some of you may be knowing about cold fusion. The cold fusion was the fusion of deuterium and tritium or deuterium in the laboratory in an electrolytic cell. And Bounce and Fleshman became famous for this discovery, what they told that they achieved cold fusion in the electrolytic cell. And a lot of people all over the world oriented their research efforts in confirming that yes, cold fusion does happen in the laboratory or not. And after a lot of time, maybe 5 years or so, ultimately it was concluded that there is no cold fusion. So then these people had to withdraw that paper in a cold fusion. So this kind of controversial subjects better not to venture in. But I know there are still people who have interest in this area even now. It was in early 90s that cold fusion was found out, and now there are some groups who feel that yes, it is possible to achieve cold fusion, and they are still working on it. Then avoid too narrow or too vague a problem. So for a research problem, you have to have a topic where you can have some few publications. So it should not be too narrow a topic and also too vague. You have to avoid those. Then research topics should be familiar, feasible. So always take advice from the experts that yes, it is topic of interest to you. Then keep in mind the importance of the subject, the qualification and training of the researcher, and costs involved. So whatever kind of training that you will be getting, whether you have sufficient guidance in the institute for doing that work, what are the costs involved? Suppose you are planning to install a big equipment. The project involves a big equipment, whether the money is available, and the time factor in selecting the problem. So there are some big projects which might take tens of years. One can be a part of that project, but you should see that whatever work you are planning is doable in a reasonable time frame for your PhD problem. And it is always a very good idea to perform a preliminary study. So you do literature survey, you find some merit in doing some work, but you do a preliminary study before finalizing the research topic, before selecting the problem. So particularly it is a new topic, new problem. It's good to do so it's worth spending few months in doing the preliminary study that the problem will succeed or not. So there are what is called as unknown uncertainties. In scientific research, unknown uncertainties are always there. That means you make a proposal and you carry out the work. You have seen all the aspects, pros and cons of that research problem. But at the end of the project work, you may find there are some surprises. So that surprises may not be leading to success of the project. They are called unknown uncertainties, and that under uncertainty, it can happen. So it is not necessary that every research problem will lead to useful results, but then you will learn a lot from that particular problem. So when you are doing some work, there are large number of people who might have burnt their fingers and found out that this problem is not worth feasible. So we can be wiser. We can learn from their experience and not to repeat the mistakes. Okay. So some of the sources to identify the research topic are given below. So you can have a theory of your own interest. Many of our mathematics friends may like to develop some new theory, or even the physics. In the physics also, people may develop new theories. Then one can take up problems of daily, which we encounter daily or in social life, like AIDS, acquired immune deficiency syndrome. A lot of people are working on research to treat AIDS. Viral infections, you are aware of the coronavirus, and many people have oriented their research work towards finding the vaccine as well as medicines for COVID-19. Then air pollution, one of the burning problem of our whole world. Then afforestation and deforestation, both are important. So people are doing research. Child labor, it's a social problem of aged people. So aging. People are working on how to retard the aging process. All these are problems, and there one can really contribute in a small step. Then there are technical challenges, technological challenges. I have just listed some of them, but there will be, I'm sure there are many of them, like conversion of cellulose into ethanol. You must have heard about Ramar Pillai, who became famous, who claimed that he has converted this cellulose into ethanol, but somehow it did not, it could not be repeated, it was produced. Then, of course, the energy problem, hydrogen energy from water, splitting of water. And so a lot of work is still already going on, but one can always find a better catalyst for higher efficiency process. Then fusion reactor, the ITER, the whole world, many countries are contributing to the fusion reactor to achieve the Lawson's criterion in ITER. So many countries are working on magnetic confinement of the plasma for a reasonably long time with a high plasma density. Then there could be recent trends, and these trends keep changing, with time. The nanotechnology, molecular electronics, artificial intelligence, etc. And you may think of many other trends which are recently coming up. Then there are unexplored areas like behavioral science, our clinical psychology, people may like to work on. Mimicking nature. There is a lot to learn from nature, and this what makes the fringes on the butterflies, the feathers. So very interesting thing. Like not a lot of nanotechnology is there in this nature also. Ayurveda is one of the areas. People have started working on Ayurveda recently. And of course, many of our students are involved in mega science projects like LIGO, INO, energy physics, and so on. There are many other, even ITER is a mega project. So these are some of the examples I thought, just typically, how one can choose a problem. I know that you have already joined a group and already started working. So it is not possible that you suddenly start changing based on what I am discussing. I'm just giving examples, and you may be already in one of them. So it is important to discuss with experts and your thesis supervisor to choose a problem, and we'll discuss a little bit more of this. And as I mentioned the other day, Sanjeev Kapoor's advice, try to do excellent work in whatever you take, whatever work you are doing, try to excel. Don't remain mediocre. If the topic may be excellent, but don't remain mediocre. So work hard to do an excellent job. Okay. So once you have chosen the topic, you have to formulate the problem. And for this, maybe, it's good to make a checklist type thing, You state the problem in a questionnaire form or in an equivalent form and answer those questions if you are, to test whether this problem is good. Specify the problem in detail and in precise form. Whatever assumptions you are making, you list them. If there are any ambiguities in your assumptions or the problem that you are, idea that you have, remove them. And then examine the feasibility of a particular solution. What are the possible scenarios that you may come? So this is the most crucial part of the research study and should not be defined in a hurry. So good to spend a couple of months probably reading in the library. I will discuss that in the library work, and then come to a topic conclusion that this is the topic you would going to pursue. So how to assess if the defined problem is a good one? Ask some questions, and depending upon the answers that you get, you will be able to know whether it is worth pursuing or not. So in order to ensure the statement of the problem is proper, you ask the questions to yourself. Is the problem really interesting to the researcher, to you? and to the scientific community. So it is important to ask the interesting problem. Is the problem significant to the present status of the topic? So it should be the topic that should be of relevant in the present circumstances. Is there sufficient supervision and guidance? Do you have the expertise in the institute, whether the proper guidance you will be getting? And can the problem be solved in the required time frame? If it is a mega project, then of course you will be handling a small portion of that mega project. But if it is in your laboratory, it's good to think about whether we can do it in that time frame. And then also important is, are the necessary equipments, adequate library and computational facility available? So if when you make the research design, all these come into picture that you will be needing library facility, you will need computational facility, you will need these equipments. So just see whether they are available. And if the answer to our questions are yes, satisfactory, then the problem can be taken for the study. So that is what is the way out. Just to illustrate, how to zero in on a problem. So to remove the ambiguities. Just I have taken this from a book on research methodology of defining a research problem. So initially, this is the question: why is productivity in China so much higher than in India? All of us know that China is doing excellent and they are highly productive. So if you take up this research problem, why China is more productive than India, you may have ambiguities in this, because it's difficult to attack the problem in a specific way. So this question has ambiguities, like what sort of productivity is referred to, and with what industry the same is related, with what time period we are talking about. So all these questions are there. Say that the question which is asked in the beginning is a little bit ambiguous. So you can make it narrow down to this question. So you can focus it more, like what factors are responsible for the higher labor productivity. So in China labor is very cheap. So what factors are responsible for the higher labor productivity in China's manufacturing industries during 2011 to 2020 relative to India's manufacturing? So you have tried to make it more focused, and you can further make it more focused by rephrasing it at to what extent did labor productivity in 2011 to 2020 in China exceed that of India in respect of 10 selected manufacturing industries. So you can choose 10 manufacturing industries and find out, study to what extent this productivity in this decade in China exceeded that of. So you are able to quantify the outcome of your study. So that is what is important in focusing on your research problem. Another research problem which I have taken from one of the books, very interesting one. So this is a topic of life sciences, evolution and adaptation, how different species adapt to the changing scenarios. So it is like, there are two lakes called A lake and B lake, and lake B is bigger than lake A. And there's a small fish called three spines sticklebacks, that the upper one. This one has three spines. Sticklebacks, they are called sticklebacks. They live in both the lakes. And lake A has another fish called trout. It's like a salmon, which preys on sticklebacks. So one of the lakes has got the predator, trout, and other one does not have the predator. The three spines on the back of sticklebacks deter the trout from eating. So it is the defense mechanism of the small fish against the predator. So one may think that larger the spines on the stickleback, more effective the sticklebacks in warding of the trout. So they should be actually devolving to have larger spines in the A, where the trout is there. So therefore, the spines on sticklebacks of A lake should be larger than that in B lake. So it is a very interesting problem. You can do an experiment now. You can take fish from lake A and lake B and measure the spines from this fish, and later on do a statistical analysis, which we will do in the next few lectures, subsequent lectures, whether it is statistically bigger or not. So whether the spines of the stickleback in lake A, where there is a predator, they are bigger than that of the spines in lake B or not. So this kind of a problem is a very interesting research problem to tackle and do a lot of analysis. So this was one of the first is to how to define the research problem. The second aspect, even research literature survey also helps you in defining the problem more accurately. So literature survey essentially involves collection of research publications, books, and other documents related to the defined problem. So what are the sources, documents that one has to look for? So you can have journals which publish abstracts of papers published in various journals. There are only book of abstracts, Some of the journals have only abstracts of the papers. Then there are review articles. Some journals publish review articles, reviews of modern physics, like physics reports, chemical reviews, and so on, related to the topic chosen. Journals which publish research articles, so they are the ones which are normally will publish our papers in. Then advanced level books on the chosen topic, there are monographs, advanced books. Then proceedings of the conferences, workshops, etc. It is very important to look at the proceedings also, because many of the publications in proceedings they not appear in the journal form. Then reprint and preprint collections available with supervisor and nearby experts working on the chosen topics. So get hold of the topics, the papers from your seniors. And of course, you have the internet always available and at your tips of your fingers. So, but then internet, it has got its own plus and minus points. Okay. So why to do literature survey? The literature survey helps us in sharpening the problem, reformulating it, or even leading to defining the closely related problems. So it helps us in making a focused approach to formulating the research problem, because you read the papers which people have done the work, similar work, and you will see that itself helps you how to define a research problem. Then it helps you to obtain a proper understanding of the problem chosen. So when I was telling that you take a couple of months to define a research problem, essentially you are doing a good literature survey whether the problem has been already handled or not, and how people have approached this. Acquire proper theoretical and practical knowledge to investigate the problem. So you know from the literature what kind of modeling, what kind of models are required, what kind of experiment instruments are required to carry out your problem. It also helps us to show how the problem study relates to previous research studies. So when you are taking up a new problem, it could be an extension of a problem which have been handled by previous people, and know whether the proposed problem has already been solved. So many a times, if you have not done an extensive survey, you may land up in a situation where after publishing, you find that it is already done. And I give you my own example. Good to give our own failures. So see, failures are the stepping stone for the success. But don't feel rejected if your experiment fails, or if you do something which was already done. It can happen with anybody. It happened with us in 1988. So this is a paper we published in Physical Review C, rapid communication. We were so enthused that we discovered a new isomeric state of 131 antimony. So we went to VCC, Kolkata, where we have a cyclotron, and in the alpha beam, we bombarded uranium, separated radiochemically antimony fission products. And we found that 131 antimony having half-life of 23 minutes decays to tellurium and then to iodine. From the total activity of iodine, we found that there has to be an isomeric state of 131. And we did we got convinced that yes, there is a isomeric state, which is not reported in the literature. And we published it in Physical Review, 1988. The moment we published it, within a month, we got a mail from one of the professors who said that he has already studied this problem, and this is not 131 antimony, it is 129 antimony. Now you see, 131 and 129, they are the isotopes of antimony. And what we had done is we had done radiochemical separation. We did not do mass separation. Whereas this group has done mass separation of iodine 130, antimony 131 and 129, and they could unambiguously prove that this activity is due to 129 antimony. So once we saw that paper, so that paper appeared in such a way now, it just appeared actually a few months back before we published this one. And then we wrote an erratum to Physical Review C. The moment we came to know that we have published a result which is not correct, we wrote it. So this is the way you write an erratum that our data is not proper. So this is how it has to be done. So you learn from your mistakes, and no, if we did not know, ignorance. So best that the lesson to learn is that do a good literature survey before somebody points out to us that no, we have not done a proper survey. Then this literature survey helps in identifying gap areas in the subject. So when you read all the literature, you will find there are some gap areas, and that is where you make a problem definition. Sometimes, the problem may not be feasible, or there may be unsurmountable difficulties. Again, I give you my own example. So this time differential perturbed angular correlation is a hyperfine interaction technique, which is a nuclear probe technique which requires a radioisotope emitting 2 gamma rays in cascade. And this intermediate level should have a lifetime more than 1 nanosecond. So we have been working on this area, and I found that 154 europium has got very good decay characteristics, having 9 years half-life, has got gamma rays in cascade, intermediate level lifetime more than 1 nanosecond, and all that. But there were no papers in literature where 154 europium has been used as a TDPS. Only one paper from a professor in TIFR, he published in a conference paper. I read that paper also. And so we did a simulation study. It's not that we published papers on, but we spent about 6 months time on this isotope to be used as a TDPSC probe. So we can study the chemistry of europium in solid state. But then we found that there were difficulties. There are several gamma rays of 154 europium, and it was difficult to resolve the gamma rays using a sodium iodide thallium. This kind of problems arose. So these are the difficulties, but initially we were very much enthused that we are going to use a new probe nucleus. So this kind of thing can happen if you don't do a proper literature survey. Now, I am an old timer, and I recollect how we used to do literature survey in the 80s. So in fact, in golden times, you have to go through the library. We did not have internet at that time in 80s. So there are abstracts, chemical abstracts, nuclear science abstract, and similar aspects for physical and mathematical and all types of sciences. For nuclear research, there was INIS database for nuclear science. So what you to do, there was a stepwise process to do literature survey. It used to take a lot of time. Like we used to make a collection of keywords, like subject index. So there are volumes only containing the subject index. So alphabetically, you look at the keywords of your interest in the subject index. So these are the volumes of subject index. Then from that, you note down the abstract number. Then you go to the abstract book. There are books of abstracts where only abstracts are given. Read the abstract and you find that it is interesting to pursue this paper. Then you note down the reference from that book of abstracts, go to the journal, then read the full paper. So you see, it's a three-step process to do literature survey. First, read the subject index, go to the abstracts, then go to journal papers. And we used to spend months together in library noting down these numbers in the register. Now, of course, internet has revolutionized the literature survey. So it provides a range of new opportunities for collecting information. It also helps in networking, conducting research, collecting data remotely, and disseminating our research results very quickly. Internet, then you have the electronic mail systems, you have e-journals, online submission of articles to journals. So publishing has become very fast now. And the online video conferencing that we are having, lectures through online lecture classes and online questionnaire. You can even have the examinations held online. So these are the latest tools opened up by the internet. So it is really revolutionized. Now the time frame for publishing papers, collecting literature reports have become very, very short. But it has thrown many new challenges, and we should be careful. We should take note of these challenges, like reliability and accuracy of obtained data. So, for example, this Wikipedia, no? When you type something in Google and it takes you to the Wikipedia. Wikipedia is developed by people like us, and many a times you will find information may not be authentic. So you cannot rely on the data from many of these sources. Then ethics of conducting research onto online communities. For example, if you collect information from the literature, then there are ethical issues in reproducing the data from the online. Like, if you are doing a modeling, you collect the data from literature, experimental data, and do the modeling. So there are ethical issues. Then physical access and skills required to use the technologies involved. So unless you can learn from internet, but unless you really have the physical access to the literature or whatever skills you need in the technologies, unless you go to the laboratory, do the things, literature, internet alone may not help you in the research problem. Then very important aspect is change the chronology of interaction, resulting from asynchronous communication. So when you select, for example, you do a search, if you don't get timely information, you get the information first, which is done later on. So you are not able to know what way this particular subject developed in time frame. So it is very important to follow the chronology of the development of a particular subject, and that is why you need to go to the books, review articles, and so on. So what are the literature search engines that most of you probably now you are more savvy than me. So Google is the most, nowadays Google, you can chat to Google, ask Google to do many tasks. But then the problem with Google is no filtering. So it does not know what you are interested in. You just put a keyword, it gives you some information. Many of it could be junk. So it's a time consuming process because a lot of the information that you get from Google may be junk, may not be relevant to you, and you may get some stray information. So it is not really a good literature survey. If you give the direct DO in this particular journal name, type, subject, title, reference, proper reference, if you give, you may get the proper information, but otherwise you don't really get good information. So you go for the specific search engines like Scopus, Science Direct, Web of Science. American Chemical Society has its own search engines, a Physical Society also, then LCBR, Royal Society, Springer, and now this is a very interesting, you may be knowing, Sci-Hub. In Sci-Hub, if you type the Google DOI number of a particular article, then this Sci-Hub will give you the complete paper, even if you do not have the authorization or your institute doesn't have authorization to see this paper. So Sci-Hub is a excellent search engine. There's some people, I think, Russians or some people in Europe, they have developed this hub where, because this problem of language is there now, so they have translated all the literature into English and then put them in a place where journal researchers can see that full paper. So I could see it's very useful. What you need to know is the DOI number of the paper, and you can get the full paper. In BARC, we have the Lakshya, the engine where you can do literature survey. So our library and information services division has done an excellent job. It's an online information gateway for BRC scientists. Lakshya aims to provide internet digital resources to BRC scientists and engineers for their R&D activities. Many of the other organizations may also have similar portals. It was set up in 2002, December 2002, and currently more than 2,500 e-journals and other e-resources are available on Lakshya, majority of them with full text. So I don't know whether other CIs can access Lakshya, but certainly your friends in BRC can help you. Then the reference collection. It is important to have a collection of all the whatever literature you are doing, survey you are doing, collect the literature. So a complete literature survey requires thorough screening of literature in one's field of interest. So it's not, you cannot say later on, oh, I did not know this work has already been done. So to make sure whatever you are, like I have been emphasizing, you must be adding new knowledge to the existing knowledge pool through your research work. So make sure that whatever work you are doing, it is new. And therefore, use search engines to find using the proper keywords of interest and look for publications in the particular area. And there is a journal called Current Contents. It comes periodically, a journal published weekly and available in hard copy form in libraries. It gives the table of content of research journals and magazines in various subjects. So you note down, so you are update current content, like we used to go on every Monday morning. We used to have the new arrivals in library in BARC. And so Monday morning, half a day you spend so look at the new arrivals, books, monographs, and the current contents. We also have in India a network called Information and Library Network Center, InflibNet, which provides this service through 6 institutions. And so you can access this network of information through www.inflibnet.ac.in. And it is also, you can also go to IISc Bangalore or JNU. So you can order papers from InflibNet upon payment of this. So these are the interesting portals through which you can get the literature. But I know most of your CIs have excellent libraries, and they also have authorization to access the online journals. So when you write a typical reference, you have the author list, title of the paper, author list, journal name, volume, start page, end page, and year. Like, this is one of our papers, investigations of complete and incomplete fusion in carbon. So this is a title, then this is a list of authors, the journal, page numbers, and the year. So that is how you start learning how to write a reference systematically. Okay. So last slide. So it is good to assess the current status of the work that you are going to embark upon. You read the relevant journals and the recent papers. Even some of the papers may be published in discussion in conferences, seminars, and workshops. So sometimes Google gives you that information that papers are published in conferences, but conference proceedings may not be reachable. So, but then if you do a good literature survey, read the review articles in your area, you will come across even this conference literature also. And also you need to attend the conferences and workshops so that by the deliberations of the seniors in invited talks, you come to know a lot of knowledge, whether it has been done or not. Also read the review articles on the subject and books, monographs to obtain a complete understanding of the subject before you make a selection of a problem for your research. Very, very interesting to tell you that make a practice to maintain notebooks containing the literature on a particular topic, because many a times it's good to write. So you may be reading it from the PC or laptop, and later on just storing that paper in the folders, and then you have a large number of folders and you don't know where you kept it. Similarly, we have a habit of xeroxing article thinking that we will read it later on, and you store the articles in PC, you download, store in PC or Xerox. But if you Xerox an article, chances are that you might not read it later, because you keep on Xeroxing, but later on you don't have time to read them. So best practice is to, whenever you are doing the literature survey, you read it then and there. Similarly, when you download an article, immediately first you read it, then download. Xerox, when you are Xeroxing, read it and then Xerox it, so that for referencing you may be Xeroxing it, but later on when you have piles of Xerox papers, you may not be able to even trace this one. So it's a good practice to sit in the library and read and all the literature and make a note of your own, way, what is the outcome of this study. So in your own words, try to make a précis of the understanding that you have got by reading the article. So this is a churning process. Gradually one understands how to write. It also helps you in writing paper. So somebody has written some paper, you write in your own language, what is the work people have done, why they have done, what they have achieved and all. So it's a good practice to write in your own way, even if you can type in the PC, in your Word file, but you write it in your own way. So you understand when you write it in your own language. So that's all I have to say today. If you have any questions, you can write in the chat box. So let me stop sharing. Let me open the chat box. Yes. I have a question related to fish problem. As I understood, the stickleback fish are adopting to a revolutionary stable strategy. However, to observe this effect in action, it requires a very long time. It can be observed after a few generations in the stickleback fish. Okay, it's an interesting observation. Gee, this sticklebacks have been there probably for a long, long time, and maybe the genetic changes that happen in the fish that already has happened. So if you pick up the fish from the two ponds, in fact, I will discuss this data in the next subsequent lectures when we will do the statistical analysis of this data. So that time we will find that we have the difference may be very, very small, but the statistical analysis of the data is most important when arriving at the. So it is not that you first introduce them and then it might have happened already, whatever you are telling, that it may take few generations of time. So it might have already happened. Any other question? I have a question related to Sci-Hub. Although most of us are using it, is it ethical to use Sci-Hub as it provides the content to users without having the access? So it is purely ethical. It is available. So you see what is ethics. You will have lectures on research and publication ethics. when you are publishing, uh, when you are publishing a knowledge based on a journal, and you are referring to that journal. So in your references, you are mentioning the reference number. So there is no problem in referring to a paper and quoting from that paper. Whatever knowledge that paper has given you, you can use it for your interpretation or all that. So there is nothing wrong in not reproducing, using that information in your work. Let me go up whether any other questions are there. I think questions are only at the last. Any other question? I have a couple of minutes before we close. I am also given to understand that some students have not got the login ID, though they registered before 17th, but their email ID was not properly written. They did not write the email ID properly, and that is why they did not get the login ID properly. So there is a portal in Anuvidya itself, the middle portal. For our course, there are 3 portals. So the middle one, generate login ID. So I got some emails from 3-4 students who did not get the login ID and password. They can go to Anuvidya site who have registered before 17, on or before 17, and generate login ID and password. I have sent to some of them, I have sent the SOP to how to generate that. But in case some people did not get that, they can write back to me. We'll help them. For those who have registered before 17 but did not get the login ID and password. Okay, then we'll wind up here. Thank you all and all the best. Okay.